The year is 1941. World War II is spreading across the globe. Europe is already burning in war, and the Atlantic Ocean has become one of the most dangerous places on Earth. German submarines, called U-boats, are attacking Allied cargo ships every single day. These ships carry food, fuel, weapons, medicine, and soldiers to Britain and other Allied nations. But there is a huge problem. The ships are sinking faster than new ones can be built. Britain is desperate for supplies. Without cargo ships, the country could starve and lose the war. The United States knows it may soon enter the conflict too, so America needs a fast solution. The answer is not to build perfect ships. The answer is to build thousands of simple ships as quickly as possible. That is when the Liberty ship is born. Officially, it is called the EC-2SC-1 cargo ship, but most people simply know it as the Liberty ship. President Franklin D. Roosevelt once called them ugly-looking ships. Many people agreed. They were not beautiful, fast, or modern, but they became one of the most important ships in history. To understand the Liberty ship, you first need to understand how amazing its production really was. In 1940, British experts came to America with the design of an old cargo ship. The design was simple and slow. In fact, parts of the design came from ships built in the late 1800s. Normally, shipbuilding takes years. Skilled workers carefully build each part by hand. But American industrialist Henry Kaiser had a different idea. Instead of building ships slowly, he wanted shipyards to work like car factories. Large sections of the ship were built separately. One group built the bow. Another group built the stern. Others built cabins, decks, and engine rooms. Then giant cranes lifted these sections together like giant building blocks. This method was called prefabrication. It changed shipbuilding forever. Another major change was welding. Older ships used thousands of metal rivets to hold steel plates together. Riveting took a long time and required skilled workers. Liberty ships used welding instead. Welding was faster and easier to teach. Because of this, many ordinary people could quickly become shipyard workers. Thousands of women also joined the workforce during the war. They became famous as Rosie the Riveters. They worked long hours welding steel, operating cranes, and helping build ships at incredible speed. Before the war, building one cargo ship could take many months. Now, Liberty ships were completed in around 42 days on average. One famous ship, the SS Robert E. Peary, was built in only 4 days and 15 hours. That sounded impossible, but America's factories were producing ships at an unbelievable rate. Eventually, over 2,700 Liberty ships were built. It became the largest single class of ships ever produced. So what exactly was a Liberty ship? The ship was around 441 feet long and 57 feet wide. It was not designed for beauty or speed. It was designed to carry huge amounts of cargo. In simple terms, the ship was shaped almost like a floating box. Its wide body allowed it to carry more than 10,000 tons of supplies. Inside the ship were 5 giant cargo holds. 3 were in front of the engine room. 2 were behind it. The ship carried almost everything needed for war: food, ammunition, fuel, vehicles, airplanes, tanks, medical supplies, sometimes even troops. Many Liberty ships were packed full from top to bottom. Some even carried extra cargo tied directly onto the deck. To move all this cargo, the ship used steam-powered cranes and winches. These machines loaded and unloaded heavy supplies at ports around the world. The Liberty ship was not luxurious. It was noisy, crowded, and uncomfortable. But it was strong enough to cross dangerous oceans carrying life-saving supplies. And that was all that mattered. Now comes one of the most interesting parts of the Liberty ship: its engine. By the 1940s, many modern ships already used steam turbines. These engines were more efficient and advanced. But turbines were difficult to build. Factories producing turbine engines were already busy making engines for warships. So engineers made a surprising decision. They used an older engine design from the 1800s. It was called a triple expansion steam engine. Even though it was old-fashioned, it had several advantages. It was simple, reliable, cheap, and easier to mass-produce. 18 different companies built these engines during the war. The parts were standardized, meaning pieces from one factory could fit engines built in another factory. That made repairs much easier. Deep inside the ship were two giant oil-fired boilers. These boilers heated water until it became high-pressure steam. The steam became extremely hot and powerful. This steam then moved through three large cylinders inside the engine. First, the steam entered the high-pressure cylinder. The steam pushed a piston downward. As the steam expanded and lost pressure, it moved into a second, larger cylinder called the intermediate pressure cylinder. Then finally, it entered the biggest cylinder of all, the low-pressure cylinder. Each step squeezed more energy from the same steam. That is why it was called a triple expansion engine. All three pistons connected to one huge crankshaft. The crankshaft turned the ship's propeller. The propeller pushed the ship through the water. The engine produced about 2,500 horsepower. That may sound powerful, but the ship was extremely heavy. As a result, Liberty ships traveled at only about 11 knots, or around 12 miles per hour. Very slow. But speed was not important. The goal was simply to keep supplies moving. A fully loaded Liberty ship could travel around 19,000 nautical miles before refueling. That allowed the ships to cross entire oceans. Interestingly, if you have seen the movie Titanic, the giant engine room scenes look very similar. That is because Titanic used the same basic engine technology. Some scenes in the movie were even filmed inside a real Liberty ship called the SS Jeremiah O'Brien. Operating the Liberty ship's engine room was hard work. Usually, 3 crew members watched over the machinery. An engineer controlled the system. A water tender monitored the boilers. And an oiler kept everything lubricated. The oiler had one of the hardest jobs. He constantly walked around the engine room carrying oil cans and grease guns. The machinery needed constant lubrication to keep running smoothly. One interesting system used simple pieces of yarn. Small boxes filled with oil had yarn hanging inside them. The yarn slowly pulled oil upward and allowed tiny drops to fall onto moving parts. This simple system worked automatically for hours. Crew members just needed to refill the oil and check the yarn. The engine room was hot, loud, and covered in oil and steam. Workers often checked bearings by touching metal parts with their bare hands to feel if they were overheating. Safety standards during wartime were very different from today. Above deck, loading cargo was another difficult task. The ship's cranes and winches also ran on steam power. Steam from the boilers traveled through long pipes up to the deck machinery. Operating these cranes required skill and teamwork. 2 operators controlled separate winches at the same time. One cable pulled while another released. Both operators had to move perfectly together. Steam-powered machines also reacted slowly. Workers listened carefully to the sound of steam pressure to predict movement. One mistake could drop a tank or heavy crate directly into the cargo hold. At ports, local dock workers called stevedores usually handled unloading. They worked quickly because every hour mattered during wartime. Even though Liberty ships were extremely successful, they had a serious hidden problem. Some ships suddenly cracked apart. In 1943, a large tanker named SS Schenectady suddenly split almost completely in half while sitting quietly in harbor. Later, another ship called the SS John P. Gaines broke apart in freezing weather near Alaska. Over time, around 1,500 cracking problems were reported. Some ships completely broke in two and sank. People first blamed welding. Since Liberty ships were among the first large welded ships, many assumed the welds were weak. But scientists discovered the real problem was much more complicated. A metallurgist named Constance studied the broken ships carefully. Her discoveries changed shipbuilding forever. She found two major problems. The first problem was the ship's design. The cargo hatches had sharp square corners. In engineering, sharp corners create stress points. When the ship bent in rough seas, pressure concentrated heavily at these corners. Cracks often started there. In fact, more than half of major fractures began around hatch corners. The second problem was the steel itself. At normal temperatures, the steel bent safely. But in freezing cold water, the steel became brittle like glass. Instead of bending under pressure, it suddenly cracked. When giant waves slammed into the ship, stress built up quickly. A crack could start and spread across the hull at incredible speed. Older riveted ships had small gaps between steel plates. These gaps sometimes stopped cracks from spreading. But Liberty ships were welded into one continuous structure. Once a crack started, nothing stopped it. The crack raced through the ship and sometimes split it completely apart. Once engineers understood the problem, they quickly made improvements. Special steel reinforcements called crack arresters were added to ships. These helped stop cracks from spreading. Engineers also replaced square corners with rounded designs. Rounded corners spread stress more evenly. New steel formulas were developed too. Scientists added more manganese and reduced sulfur in the steel. This made the steel stronger and less brittle in freezing temperatures. The research from Liberty ships helped create modern fracture mechanics, the science of understanding how materials crack and fail. Even today, engineers still use lessons learned from Liberty ships. Despite their problems, Liberty ships succeeded. They completely changed the war. German submarines could not sink ships faster than America could build them. The Allies simply overwhelmed the enemy with production. American shipyards produced millions of tons of cargo shipping every year. These ships carried fuel, weapons, food, tanks, aircraft, and soldiers across the oceans. Without Liberty ships, the Allied victory might not have been possible. Most importantly, they proved the incredible power of industrial production. The Liberty ship was never glamorous. It was slow, ugly, noisy, and uncomfortable. But it did exactly what it was designed to do. It kept supplies moving during humanity's largest war. Today, only two original Liberty ships still operate. The SS Jeremiah O'Brien in San Francisco, and the SS John W. Brown in Baltimore. Volunteers still maintain these historic ships. Their boilers still produce steam. Their giant pistons still move. And their decks still echo with the sounds of old machinery. These surviving ships are more than museums. They are living reminders of the workers, sailors, engineers, and ordinary citizens who helped win World War II. The Liberty ship may have been called an ugly duckling, but it became one of the greatest workhorses in modern history.